I wanted to just kind of summarize the two different tests that we have done in these last two chapters, because they are very similar and they look really similar. No. They are similar and look very similar, but yet you do write things a little bit differently. And so I think what I want to do first is actually just kind of lay out all of the little details of the differences between these two things that we have just recently done. All right. So it doesn't really matter that you know by name what chapter 24 has in it or what chapter 25 has in it. I just put those there because those are the last two ones we've been doing. Chapter 24 covered two separate samples. Two separate samples of data. And then chapter 25, which we learned about yesterday, was actually one sample with, two sets of data. Two sets of data. For example, if you had twins, you had sets of twins. Those would be matched pairs. You could also have the before and after sets of information. So that's common ways to have our paired data. All right. So what I want to do is kind of go through the phantoms and also some little panic information, and so talk about the difference there. So if we were to do a parameter for these two things, and so we're going to show what the parameter looks like for both of these. What would it look like if they were two different samples? If we were going to do the parameter for two different means, how would we define them? We would actually we would have mu of whatever the first thing is, and we would say this is the average, whatever, height of the men, okay? And then mu of the second group, maybe it's the women, and we would say this is the average height of all women ages 20 to 30, whatever. Okay. But when we paired the data, how was that different? Do you remember pairing the data? Yesterday, we ended up with only one mean. And do you remember it was we put data in L1 and we put data in L2, and then we found what in L3? Good. L3 was that list of differences. So we would do this, and we typically would do L3, we typically made the second group of data minus the first so that we could see the way that it went. And so we only had one average, change, or the average difference in job satisfaction, or the average difference before and after the treatment, whatever. So that's the key that happens whenever you do the parameters. Okay, so now what comes next in a phantoms model? Our hypothesis statements. Okay, so based on those parameters, how would the null hypothesis and alternative hypothesis look for these two different things? See if you can't write that down and figure out what you think that would look like. Okay, so the left side over here with the two separate samples, how does that null hypothesis look? Very good. We're wondering if the two different averages are the same. And then the alternative would be that mu of 1 is, whichever, greater than, less than, not equal to, whichever that is, mu 2. Okay, very good. But then how is that different for over here on the right-hand side where you actually only have one mean? Very good. It was that mu of the differences. It would be 0 if there is no difference. If that treatment is not having an effect, then the differences would be 0. But if the treatment is having an effect, then the differences are greater than or less than or not equal to 0. All right, very good. Okay, let's keep going on with that. So let's do assumptions, but it's not going to be, with the assumptions, I'm not going to go ahead and write out like all of the get real and the assumptions. But what I want to point out is on the left-hand side, when you have two different samples, your assumptions are done for both groups. You are doing the assumptions for both groups. You will say things like, the 50 men and the 50 women are both randomly selected. And the 50 men is less than 10% of all such men, and the 50 women is less than 10% of all such women, and all that kind of stuff. But you also are making sure to say that these two samples are what? Very good. Are independent of each other. So that was the thing that we had to watch for and be careful of. Are independent of each other. Meaning nobody in group 1 is also accounted for in group 2. All right. But for our paired data, we have only one set of assumptions. It is the assumptions, not on the list 1, not on the list 2, but the assumptions made for the differences. So the one set assumptions on the list of differences. Okay, very good. Now, remember this. It is paired data. So, those two numbers are absolutely related to each other because they are made off of one person. But what was the thing that we were saying about, say, for example, on our problem yesterday where we had one worker and he got a before and after job satisfaction, and then we had worker number 8 before and after. What were we saying about those two workers? Good. The pairs are independent of each other. So worker number 1's data is not affecting worker number 8's data, or subject number 2 and subject number 10. Pairs are independent from other pairs. That's where that independence comes in. All right, very good. Okay, so in our phantoms model, we've got our parameter, we've got our hypothesis, we've got our assumptions, and what comes next? The name. Very good. So let's figure out what the names of these two things are. So over here on the left and on the right, let's compare those things. What did we call the ones over here on the left? Yep, 2 sample or 2 mean. Oopsie, I wrote that wrong. 2 mean t-test. Now, our calculator uses the word sample, but technically you would have to say 2 sample t-test for means. So I try to shorten it for you, and I just let you say a 2 mean t-test. And we're going to go ahead and put the other things in here too, because I'm going to kind of show some work on both of these. Or we might have a 2 mean t interval, depending on if we are doing a phantoms or a panic. Okay, but how about over here on the right-hand side? What do we call that? We would call that a matched pair t-test. And a matched pair, if we were doing an interval, matched pair t interval. Okay, now at this time I actually want to take a moment and reference the calculator steps, or like where you find this in the calculator. So will you look at your calculator real quickly? And let's look at the menu. So let's go kind of visualize the menu. Go stat over to tests. Okay. So I have got that happening right here. Okay, so here is a picture of what your menu looks like when you go stat over to tests. And so let's do the ones over here on the left-hand side. What is the thing that we're looking for in our TI-80 whatever calculator for the two sample things? Right here, this number 4, two sample t-test. They don't use for means. They just say two sample t-test. And then what would we do for the interval? It's down here on my calculator. It's 0, letter Z, or number 0 in the menu. Okay, so those two right there, those are the ones that go over here on the left. Okay, very good. So let me move that on over here. So the calculator, we're either going to be, it's called two sample t-test in your calculator, or two sample t-interval in your calculator. All right. How about now, what is it for matched pairs? Okay, what is it for matching? What menu item did we go to for the matching? Good, just t-test and what else? T-interval. Okay, so for our matched data, we used t-test and t-interval. All right. Okay, so I just wanted to connect that in your calculator. And so off that goes. And now let's see. Where would we be next in our, if we were running a test? Good, we would be to the phantoms. So let's go, the T. And a T stands for what? Your test statistics. So our calculator, in both cases, plops that out for us. So we would write, you must include the t-score. You must include the p-value. Okay, so both of these, the calc is the same. The calculator just gives you these things all nice and tidy. Where we have some differences is the DF. And we know we must include the DF, okay? But it might be a little bit different on the left than it is on the right. On the left, when we have two samples, the degrees of freedom are given by the calculator, because two sample degrees of freedom is a really funky formula that we don't have to know how to do, so the calculator does give that to you, and you know sometimes it's that decimal number. But over here on the right, it's just one sample, so it is not given by calculator. It's not listed on that menu. So how do you then get the degrees of freedom for that one sample? Very good. We do the typical n-1. Okay, very good. So I just wanted to point that out to you to be aware of that. Okay, I'm not gonna continue with the obtain a p-value and make your decision and draw your conclusion. But what I do kind of want to do is talk to you about some differences if you were to do the I part of the interval, actually making the interval, how that might look different on these two things. Okay, so let's remember the left is two different means. So when we do that interval on the left, it's going to look something like this. mu1 minus mu2 colon, and then that interval gives us our numbers. Okay? But on the right-hand side, where it is just one mean, how does that look different? It's just this mean of the differences. So I just go mu of the little 2 minus 1, colon. And then I do my from one number to the other number. Okay? So, in summary, here are all those little differences that I wanted you to see from your chapter 24 and 25. Okay, does that kind of help solidify all the little nuances between those two things? Is that good? Because this is the first time I've actually done this on in class where I just really kind of laid out all these differences for you. Okay, so we'll go ahead and do that. Now what I want to do is go on over to the notes. It is on your page 42 in your packet this year. So let's go ahead and take a look at that.